Hi guys, I hope you are all doing well. Let's see today's question. So today's question we have picked up it from probability, and in this question we have been told that there are two people A and B, and both of them throw a pair of dice alternately, right? And they throw this pair of dice until one of them gets a total sum on the upper faces of the two die as 10, and the one who gets this sum as 10 wins the game, right? So we have been asked to find the probabilities of A as well as B of winning this game if A starts first to throw a pair of die. So we know, first of all, if I see the solution here, if I throw a pair of die, the total outcomes are 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, right? So 1 on the first die and 1 2 3 4 5 6 on the second die. Same way, 2 on the first die, 1 2 3 4 5 6 on the second die. Same, I can have 3 on the first die, 1 to 6 on the second die. Likewise, I can have 4 5 and 6 on the first die, and likewise I can have 6 on the second die as well. So basically both of them have 6 as well as 6 on the upper faces. So if I see, I have here 6 6 6. For 4 it will be 6, for 5 it will be 6, and for 6 it is 6. So total number of outcomes, if I talk about, I have in total 36 outcomes when I throw a pair of die, right? And if I talk about the favorable outcomes, that says that the sum should be equal to 10, right? So if I talk about the favorable outcomes here, in this case, so favorable outcomes become, I can have 4 and 6, the sum becomes 10. I can have 5 and 5, the sum becomes 10. And I can have 6 and 4, the sum still becomes 10, right? So probability of getting a sum 10, it's equal to favorable outcomes upon total possible outcomes. And if I talk about the favorable outcomes in this case, I have 3 favorable outcomes. So probability becomes 3 upon the total outcomes of 26. That makes it 1 by 12, right? So probability of getting the sum as 10 is 1 by 12. So if I talk about the idea here, if one of them wants to win the game, so probability of A winning the game is nothing but equal to probability of getting the sum as 10. So it is 1 by 10, 1 by 12. Similarly, probability of B also winning the game would be 1 by 12, because if he also gets the sum as 10, probably B wins the game. Probability of, if I talk about A not winning the game or losing the game, means A does not get the probability or the sum of the two outcomes on the upper faces of die as 10. So in that case, it would be 1 minus probability of A winning. 1 minus 1 by 12, that is 11 by 12. Same way, if I talk about probability of B not winning the game, that is again the complement of the event B. That's also 1 minus 1 by 12, that's 11 by, right? Now I have the respective probabilities. So probability of A not winning, I can write it as probability of A dash, and probability of B not winning the game is probability of B dash, right? Now, if A starts first, let's find out the probability of A winning this game if it starts first. Probability of A becomes probability of A winning the game or A getting the sum as 10, or it can be A not getting the sum 10, then B should also not get the sum 10, and then A will again get the sum as 10. So A again wins the game, right? Because we want A to win the game, right? If I talk about the next idea, can be A again not winning, then B should also not win. Again, A not winning, B should not win. And again, I will have probability of A winning the game, getting the sum as 10. Likewise, it goes till infinity. Now, if I talk about this idea, we know already probability of A getting the sum as 10, it's 1 by 12. So it can be 1 by 12 plus A not winning, so 11 by 12, B not winning, again 11 by 12, and again A getting the sum 10, so it's 1 by 12, so it's 1 by 12. Again, here I can have again 11 by 12 and 11 by 12 because A and B not getting the sum 10. Again, A and B not getting the sum 10, and then A getting the sum 10, so 1. Right? This goes till infinity. Now, what I can do here is I can take out 1 by 12 common. If I take that out, what I get? 1 plus 11 by 12 square plus 11 by 12 raised to 4 plus 11 by 12 raised to 6, and this goes on and on till infinity. Now here if I see this entire list, what is this entire list comprising of? If I take the ratio of the consecutive terms, so if I take the ratio here, it becomes 11 by 12 square upon 1. Here also if I take the ratio, I get 11 upon 12 raised to 4 upon 11 by 12 square. So that's again 11 by 12 square only. So ratio is a constant term, 11 by 12 square. And when ratio is constant, this entire list which is in the bracket, this list becomes a geometric progression. And when it is a geometric progression, we have the first term is 1. And the common ratio that I'm talking about is 11 by 12 square. So I can use the idea to find the probability of A winning the game. So if I want to find probability of A winning the game, I already have taken out 1 by 12 common. Right? And now if I apply the sum of the terms to infinity in a geometric progression, it is given by A upon 1 minus R, right? So sum of the terms, or I should say sum of the infinite terms in a geometric progression is A upon 1 minus R. So if I use this idea, I can write this as 1 upon 1 minus 11 by 12 square. So if I solve this further, what I get? Let's see. So 1 upon 12, this becomes 1 upon 1 minus 121 by 144. So if I solve this further, that gives me 1 upon 12 into 1 upon. This becomes 23 upon 144. I can cancel this 12 ones are 12 12s are. This is present in the denominator of the denominator, right? So that goes actually in the numerator. That gives me 12 by 23. So I get the idea that probability of A winning the game that was asked to us, the respective probabilities of them winning the game. A starts first. That's 12 by 23. And now if I want to find the probability of B winning the game. So basically if you understand, either A will win the game or B will win the game. So probability of both of them, total probability has to be equal to 1. Right? Because either A wins the game or B wins the game. So if I find out probability of B winning the game, it's equal to 1 minus probability of A winning the game, and probability of A winning the game is 12 by 23. So it becomes 1 minus 12 by 23, that is 11 by 23. Right? So we had been asked that find the respective probabilities of A and B winning the game. And we have got them as this is 12 by 23 and this is 11 by 20. And if you see the options which matches in this question is, so the correct answer for the question which is asked to us is B. That probability of A winning the game is 12 by 23 and probability of B winning the same game is 11 by 23. I hope you have understood how to solve this type of questions, right? We'll meet again tomorrow with the next question. Till then, you can like, share, and subscribe to my videos if you're finding this helpful. Thank you.